Okay, let's tackle another Alex problem here. This having to do with some solution concentrations. The question it talks about, one way the US EPA tests for chloride contaminants in water is by titrating a sample of silver nitrate solution. Any chloride ions in solution will combine with the silver cations to produce bright white silver chloride precipitate. We did something similar to that in lab. So here's the question. Suppose an EPA chemist tests a 200 ml samples, that might come in handy there, 200 mils, of groundwater known to be contaminated with iron 2 chloride, which would react with silver nitrate solution according to this chemical equation right here. Okay, the chemist adds a 13.0 millimolar silver nitrate, that might be important, solution to the sample until silver chloride stops forming. He then washes, dries, and weighs the precipitate. He finds he has collected 6.1 milligrams of silver chloride. We are asked to calculate the concentration of iron 2 chloride contaminant in the original groundwater sample. Be sure your answer has the correct number of significant figures as always. Okay, so we collected this silver chloride right here, and we're being asked then to find the concentration of iron 2 chloride in a 200 ml sample, or that 200 mils, I'll just hurry and convert that to liters because our answer wants liters, so that's going to be 0.200 liters. That's what that 200 milliliters is in liters. Okay, so I'm given silver chloride, try to find iron 2 chloride. So let's write down what we know. Let's start 6.1 milligrams of silver chloride. Okay, since I know where I start, we don't ever deal in grams or milligrams, but we do need to get to grams eventually, so let's go. There are 1,000 milligrams in 1 gram of silver chloride. Now that I have grams of silver chloride, I can go to moles. We deal in moles, especially when we're trying to maneuver around a chemical equation. Okay, so I know that there are 143.32 grams in 1 mole of silver chloride. I just got that from Google. I know it's cheating, but that's what I did. Alright, so silver chloride, but I'm trying to get to iron chloride. So I know that there are 2 moles of silver chloride and 1 mole of iron 2 chloride. So I'll come down here. I know that there are 2 moles of silver chloride in 1 mole of iron 2 chloride. Alright, so I'm at moles of iron 2 chloride. It's asking for the concentration in milligrams per liter. So those are the units I need to get that iron 2 chloride in. So I need a molar mass of that, so I know that there are in 1 mole of iron 2 chloride, there are 126.75 grams of iron 2 chloride. Again, it's asking for that in units of milligrams. So let's go back out. I know that in 1 gram there are 1,000 milligrams of iron 2 chloride. Okay, so I can get those milligrams out right now. If I do all this math, let's just double check here. Milligrams cancel, that's a true statement. Are there 143.32 grams in 1 mole? There are, that's a true statement, and units cancel. My units will cancel here. Moles of iron 2 chloride will cancel, and those are true statements. And finally, grams will cancel. So I'm left with 1,000 milligrams of iron 2 chloride. So if I do all of that math, I get that there are 2.70 milligrams of iron 2 chloride. Okay, but it's not asking for milligrams, it's asking for a concentration in liters. Well, back in my original vial, my beaker there, I had 200 milliliters, which I already said. Converted to liters is 0.200 liters. So I'm going to take that answer, divide that by 0.200 liters, and when I do that, the answer comes out to be 13.5. Now it's asking to get me the correct number of sig figs, and so when I do that, there's 2 sig figs right there. That's my least one. This needs to be 2 sig figs, and so the final answer is actually 14 milligrams per liter. That is the answer that should give me the correct answer in Alex. So again, just to review, I read everything. Here is the chemistry that we're doing right here. I start with 6.1 milligrams of silver chloride. I'm trying to get over to iron 2 chloride so I can use my stoichiometry. And in the end, it asked for concentration, so I knew what my original volume was. So now I could get this in units of milligrams per liter, and that's how you would solve that particular problem.